Welcome back to Operating Systems Crashcast. I'm Victor, and today we're diving into an exciting topic in our journey through thread libraries. Sheila, why don't you kick us off with a brief explanation of what thread libraries are?
Certainly, Victor. Thread libraries are essentially sets of functions or tools that programmers can use to create and manage threads in their applications. They provide a standardized way to work with threads across different operating systems and platforms. Think of them as toolkits that make it easier for developers to implement multitasking in their programs.
That's a great explanation, Sheila. Now, let's talk about the three main thread libraries that developers commonly use. Can you walk us through them?
Absolutely. The three main thread libraries are POSIX threads, Windows threads, and Java threads. POSIX threads is a standardized set of tools for Unix systems. Windows threads are specific to Microsoft Windows operating systems, and Java threads are part of the Java programming language and work on any platform that supports Java.
Excellent overview. It's worth noting that these libraries can be implemented at two levels, user level and kernel level. Sheila, could you explain the difference between these two implementations?
Of course, Victor. User-level thread libraries operate entirely in user space, without direct support from the operating system. This means they're faster to create and manage, but they can't take advantage of multiple CPUs. Kernel-level thread libraries, on the other hand, are supported directly by the operating system. They're slower to create and manage, but can run in parallel on multiple processors. Many modern thread libraries, like POSIX threads, can be implemented at either level, giving developers flexibility in their choice.
That's a crucial distinction, Sheila. Now, let's talk about some basic thread operations that these libraries typically provide. What are some of the most common operations developers need to know?
Great question, Victor. The most fundamental operations include thread creation, termination, and joining. Thread creation is like starting a new task within your program. Termination is about ending that task when it's done. Joining is a way for one thread to wait for another to finish before continuing. Other common operations include thread synchronization mechanisms like mutexes and condition variables, which help manage access to shared resources and coordinate between threads.
Those are indeed crucial operations. Now, let's compare these libraries a bit. How do POSIX threads differ from Windows threads, for example?
Well, Victor, while both provide similar basic functionality, they have different interfaces and some unique features. Threads, being a Unix standard, offers portability across various Unix-like systems. It provides a rich set of synchronization tools and allows for fine-tuned control over thread attributes. Windows threads, on the other hand, are tightly integrated with the Windows system and offer some Windows-specific features. They also have different naming conventions and slightly different approaches to things like thread creation and synchronization.
That's a great comparison, Sheila. And where does Java fit into this picture?
Java takes a unique approach, Victor. It simplifies many of the low-level details that C programmers deal with in threads or Windows threads. Java's thread model is built into the language itself, making it easier for developers to use but potentially less flexible than the C-based libraries. Java also provides high-level tools in its concurrent package, which can simplify complex threading scenarios.
Excellent point about Java's approach. As we wrap up, what would you say are the key takeaways for our listeners, especially if they're preparing for interviews on this topic?
Great question, Victor. I'd say the key points to remember are: first, understand the differences between user-level and kernel-level thread libraries and their trade-offs. Second, be familiar with the basic thread operations like creation, termination, and joining. Third, know the main differences between POSIX threads, Windows threads, and Java threads. And finally, remember that the choice of thread library often depends on the specific needs of your application and the target platform.
Those are excellent takeaways, Sheila. Thread libraries are a crucial tool in a developer's toolkit for implementing concurrent programs. Whether you're working on a Unix system, Windows, or in Java, understanding these libraries is key to effective multi-threaded programming. Thank you all for listening to today's episode of Operating Systems Crashcast. Join us next time as we continue our journey through the world of operating systems.